Hey everyone, thanks so much for joining today. Before we go further, a little bit about me. I am Denish Tomar, Dev Relet. Welcome to my talk. So let's start. I am here to talk about something that honestly keep me awake at night. And no, it's not debugging production code at 3 a.m. That also horrific. But what keeps me up thinking? That is cloud bills. Especially what's going to happen to our cloud bills when quantum computing become mainstream. So let me start with a story that happened to me just last month that made me realize we are heading for a perfect storm of confusions. So picture this. One day I hear about a person panicking. She looking at her AWS bill and it says around $10,000 for last month. Her startup entirely budget is $2,000 only. So what happened? One tiny mistake in her auto scaling configurations. Instead of scaling up to 5 servers, it scaled up to 50. And instead of running for 2 hours, it runs for 3 days before anyone noticed. So we were sitting there looking at this bill, trying to figure out what gateways processing charge means and why is he paying for CloudWatch logs data and what the hell is load balancer capacity unit. And that's when it hit me. If we can't predict cost with regular computer technologies we have been using for decades, then what's going to happen when quantum computers enter the picture? Let's be honest here, nobody, and I mean nobody, actually understand their bills. You got compute charges, storage charges, network egress charges, network ingress charges, and wait, they charge you for data incoming too. Then there's also cross availability zone transfer and API gateway request, Lambda cold start penalties, database read capacity unit, and so on. I once up lined with items for ideal load balancer time. And my load balancer was not working hard enough, and they decided to charge me for its lack of motivation. But here's the real problem. Try this. Experiment right now. Open your cloud dashboard and tell me exactly, not approximately, not around $800, exactly what you'll spend next month. You can't do it, nobody can. And this is what with technology we understand pretty well. We know how CPU works, we know how memory works. We have been optimizing these things for decades. Now imagine quantum to this equation. Here's a preview of what's coming and why you should care even if you never plan to touch a quantum computer. Your quantum algorithm might solve your problem in 30 seconds or even in 30 hours. There's literally no way to know before it might to it might re yeah. It might need to run once to get the perfect answer, or it might need to run 500 times, become quantum mechanics decide to be difficult that day. It might use basic quantum operations that cost little bit, or it might need expensive quantum errors correction that cost 100 times more. And though all this certainty, the cloud providers is going to believe for every second of processing time, for every retry, for every error correction, and for every failed attempt. The same quantum job could cost you $500 to $5,000 and you wouldn't know which until you get the bill. But before we talk about solutions, let me explain exactly what quantum computing is and why it creates the billing nightmare. All right, let's get technical, but I promise to keep it simple. Regular computers, your phones, your server running your applications, they all use bits. A bits either 0 or 1. It's like a switch either on or either off. Simple, predictable, reliable. As you can see in this slide, quantum computers use bits or qubits. Now here where it gets interesting. A qubit can be 0 or 1 and 0 and 1 at the same time. Think of it like a coin. When you flip a coin, it is spinning in the air. Is it head or tail? it actually both until it lands and you see the result. A qubit is like a coin that can stay spinning until you need to know the answer. So this is called superposition, being in multiple state simultaneously. Now, why does it matter? Because while the qubits is in superposition, it can explore multiple solutions to your problem at the same time. It's like having thousands of computers working in parallel, but they are all same quantum computer. So let me show you this with a example. Imagine you are trying to find an exit in a maze, and the classical computer approach this systematically. It will try path 1, which leads to dead end. It will try path 2, which also lead to dead end. And he will try also path 3, 4, and so on. And until he found the exit. And this takes proportional to the number of paths needs to check. And at the same time, the quantum computer can be much smarter. It puts itself in superposition and explore all paths simultaneously. Quantum state explore path 1 and path 2 and path 3 and so on at the same time in parallel. Then it collapse to the solution. For certain type of problems, this give you exponential speed up. Problem that would take classical computer millions of years can be solved in hours. But here's the catch, and this is where our billing nightmares begin. Quantum computers are fragile. Before we get to the fragility problem, let me explain one more quantum concept that make everything even more powerful and more unpredictable. That is quantum entanglement. When two qubits become entangled, they become connected in a way that defies everyday experiences. If you measure one qubit and find it 0, and other qubit instantly become 1, even if they are opposite side of the galaxy. And this let quantum computers coordinate multiple calculations in way that would be impossible with classical computers. It's like having a team of workers who can telepathically communicate and coordinate their action perfectly. So now let me show you what a quantum cloud will actually look like, because this is already happening. Here you can see in the slide a real example of what you might see. As you can see, it is too messy and can't understand too easily. So your algorithm worked perfectly. It solved your problem, but the universe decided to be expensive that day. This is why current service, quantum cloud services from IBM, Google, Amazon, and Microsoft all are struggling with pricing model. They are trying to meter the unmeasurable and predict the predictable. In short, classic cloud will like known CPU, known memory, known storage, which is leads to predictable cost. But whereas you can see cloud billing like unknown time, unknown errors, unknown retries, and don't know about cost at the end. So this is where the story get interesting, because there's a company that looked at this whole mess and said, what if we just don't? Meet Cumulus. Instead of trying to measure every quantum operations and charge you for each things, they took completely different approach. As you can see in this slide, there is a comparison between traditional cloud approach and a Cumulus approach. As you can see, traditional approach, which is step 1, measure everything, and then complex calculations, and that at the end surprises bill. And whereas the Cumulus approach, there is a predefined fixed resources, fixed prices, and then you will sleep well at night. So Cumulus believes in providing high performing fixed cost computing power instead of selling every single service and metering the uses. You can get started with Cumulus Cloud platform for less than just $100 monthly. No upfront cost, no long-term commitments, and no surprise bills. It's just like Netflix for cloud computing, and you pay for monthly fee. You get access to the platform and you can use it without worrying about the meter running. You can get started with Cumulus Cloud Platform for less than just $100 monthly. No upfront cost, no long-term commitments, no surprise bills. It's just like Netflix for cloud computing. You pay for monthly fee and you get the access to the platform. And you can use it without worrying about the meter running. Now let me explain why this approach is brilliant for quantum computing. Because Cumulus is built on OpenStack, which is open source. And this means no vendor lock-in and you are not trapped in anyone's quantum ecosystem. Let me share a real example of why this matters. I talked to a startup that moved from AWS to Cumulus. Here what changed. Before AWS, monthly bill somewhere between $800 to the $4,000. And the time spent on cost optimization is 20% of engineering time. And you can see sleep quality, ability to experiment is in the limit, and innovation rate is slow. And on the other hand, you can see at Cumulus, monthly bill is now too low, too less, and time spent on cost optimization is zero. And you can see sleep quality actually good, and ability to experiment unlimited within the resources. And other last one is innovation rate, which is 3x faster than the AWS. So the founder told me something that I'll never forget. The best part is not even the cost saving, it being able to actually build things instead of consistently optimizing for AWS pricing. When quantum computing become mainstream, this difference will be even more dramatic. Company using traditional paper quantum operations model will spend more time on time optimizing for cost than optimizing for the result. Company which is using fixed pricing model will be free to experiment, innovate, and actually solve problem. Look, quantum computing is going to reconstruct how we solve problems, but it doesn't have to be transform your budget in the wrong direction. The future belongs to the platform that understand quantum unpredictability and abstract it away from developers. So fixed pricing is not just better cloud economics, it's the foundation that make quantum innovation possible without quantum sized financial risk. So you can check Cumulus on the cumulus.io and see what transparent and fixed pricing actually means in practice. So the future is quantum and your cloud bill doesn't have to be quantum chaotic. So thank you everyone. As this is a pre-recorded talk, you can ask me any questions or anything related to tech or cloud, anything. I'm happy to answer any questions you might have. Just ping me up on the LinkedIn or Twitter. And these are my handles you can see in this slide. So you can follow me also there. So thank you everyone. Bye bye.